Imagine standing on the vast expanse of Antarctica's ice sheet, a frozen desert stretching as far as the eye can see. You might think you're looking at a barren, lifeless landscape, but what if I told you that beneath your feet lies a hidden world of wonders waiting to be discovered? Welcome to What's Buried Under the Antarctic Ice, a journey into the secrets that lie beneath the world's coldest continent. Recent scientific breakthroughs have revolutionized our understanding of Antarctica, revealing a land teeming with surprises that challenge everything we thought we knew. Picture this: an ice sheet covering an area larger than the United States and Mexico combined, in some places over 2 miles thick. But what's underneath all that ice? Prepare to be amazed as we uncover ancient river systems, vast volcanic provinces, hidden lakes, and even life forms that have adapted to some of the most extreme conditions on Earth. Our adventure begins with a discovery that has sent shockwaves through the scientific community. Imagine a landscape frozen in time, preserved for millions of years under the crushing weight of ice. We're talking about an ancient river system that once flowed freely across Antarctica when the continent was green and teeming with life. Using cutting-edge technology, scientists have peered through the ice to reveal a network of river valleys and canyons carved into the bedrock. This isn't just any river system. It's a massive landscape covering an area roughly the size of Belgium. But here's the kicker. This ancient terrain has remained virtually untouched for at least 14 million years, possibly even up to 34 million years. As we zoom in on this subglacial landscape, you'll see 3 distinct upland blocks separated by deep troughs. These features were sculpted by rivers that flowed towards a coastline formed during the breakup of the supercontinent Gondwana. Can you imagine palm trees and temperate rainforests where now there's only ice and snow? But how did scientists make this incredible discovery? It's a tale of ingenuity and perseverance. Using a combination of satellite data and ice-penetrating radar, researchers were able to map this hidden terrain. The RadarSat satellite constellation detected subtle surface anomalies in the ice sheet, hinting at the topography below. This technique, combined with existing survey data, allowed scientists to see through up to 2 kilometers of ice, revealing a landscape frozen in time. But what does this ancient river system tell us about Antarctica's past? Imagine standing on the banks of these prehistoric rivers, surrounded by lush vegetation, and a climate more reminiscent of modern-day southern South America. During the Eocene epoch, 34 to 56 million years ago, Antarctica was a vastly different place. The air was warm and humid, filled with the calls of exotic birds and the rustling of palm fronds. As you visualize this scene, consider the implications of such a dramatic transformation. How did Antarctica go from a temperate paradise to the frozen continent we know today? The answer lies in the gradual cooling of the Earth's climate and the formation of the Antarctic ice sheets. This preserved landscape offers us a unique window into Earth's climate history. It's like having a time machine that allows us to peek into the past and understand how our planet has changed over millions of years. But here's where it gets really interesting. The fact that this ancient terrain remained largely unmodified suggests that the base of the ice sheet in this region has remained extremely cold and stable for an incredibly long time. Why is this important, you ask? Well, it helps scientists better predict how the East Antarctic ice sheet might respond to future warming. And when you consider that this ice sheet contains enough water to raise global sea levels by approximately 60 meters, you start to understand the gravity of this discovery. But let's take it a step further. The Eocene epoch, when this landscape was formed, had atmospheric CO2 levels nearly double those of today. Some researchers suggest that Earth's climate could reach similar conditions in just 150 to 200 years if greenhouse gas emissions continue to rise at current rates. It's a sobering thought, isn't it? As we contemplate these ancient rivers and the story they tell, it's important to remember that Antarctica still holds many secrets. This discovery is just one piece of a much larger puzzle. Beneath the ice lie volcanic provinces, subglacial lakes, and unique ecosystems, all waiting to be explored. Now, let's shift our focus to another astonishing feature hidden beneath the Antarctic ice: Imagine a landscape not of rivers, but of fire and molten rock. Beneath the West Antarctic ice sheet lies one of the largest rift systems and volcanic provinces on Earth. This subglacial volcanic landscape stretches from the Antarctic Peninsula to the Ross Sea, rivaling some of the most impressive volcanic regions on the planet. In 2017, a study revealed the true extent of this hidden world, identifying nearly 140 volcanoes buried under the ice. Of these, 91 were previously undiscovered. Can you picture it? A vast network of volcanoes, some towering over 12,000 feet high, all hidden from view beneath a thick blanket of ice. The implications of this volcanic province are staggering. Not only does it demonstrate how much of Antarctica's geology remains unexplored, but it also raises questions about the stability of the ice sheet. Volcanic activity could potentially destabilize the ice, as the heat from eruptions or magma intrusions could melt the base of the ice and accelerate its flow. This interaction between volcanism and ice could have far-reaching consequences for sea level rise in a warming climate, but the story doesn't end there. These subglacial volcanoes might also be creating unique environments beneath the ice. Think about the ice caves near Mount Erebus, where geothermal heat creates warm oases in the midst of the frozen landscape. Now imagine similar environments hidden deep beneath the ice sheet, warmed by the heat of these buried volcanoes. Could there be entire ecosystems thriving in these hidden warm spots? Scientists believe it's possible. The combination of heat, water, and minerals from volcanic activity could provide the perfect conditions for microbial life to flourish. These potential subglacial oases might harbor organisms unlike anything we've seen before, adapted to life in perpetual darkness and extreme pressure. But how do we study something buried under kilometers of ice? It's a challenge that pushes the boundaries of modern science. Researchers use a combination of techniques, including ice-penetrating radar, seismic surveys, and analysis of meltwater chemistry. Each new discovery brings us closer to understanding this hidden world. The presence of this vast volcanic province also raises questions about Antarctica's geological past. It likely played a crucial role in the breakup of the Gondwana supercontinent, contributing to the tectonic processes that shaped the modern Antarctic continent. Imagine the forces at work as the Earth's crust stretched and thinned, allowing magma to rise and form these massive volcanic structures. As we contemplate these fiery forces hidden beneath the ice, it's natural to wonder about their future impact. Could increased volcanic activity accelerate ice melt? Might it trigger sudden changes in ice flow? These questions are at the forefront of Antarctic research as scientists work to understand how these subglacial systems might respond to a warming world. But the wonders beneath Antarctica's ice don't stop at ancient rivers and hidden volcanoes. Let's dive even deeper into the continent's secrets and explore a world that challenges our very understanding of life itself. Beneath the vast ice sheets lie networks of subglacial lakes and rivers, isolated from the surface world for millions of years. These hidden water bodies are not just curiosities. They're home to some of the most extreme ecosystems on Earth. Picture Lake Vostok, the largest known subglacial lake in Antarctica. It's roughly the size of Lake Ontario, buried under more than 2 miles of ice. The water in this lake has been isolated from the atmosphere for up to 15 million years. You might think that nothing could survive in such an environment, but you'd be wrong. Scientists have found evidence of microbial life in samples from Lake Vostok and other subglacial lakes. These microorganisms have adapted to survive in cold, dark conditions with limited nutrients, often relying on unique metabolic pathways to generate energy. It's a testament to life's incredible resilience and adaptability. But it gets even more fascinating. In 2013, researchers discovered a hidden ecosystem in a subsurface river beneath the Antarctic ice sheet. This river, flowing in perpetual darkness, hosts microorganisms that derive energy from rock minerals rather than sunlight. It's a chemosynthetic ecosystem, demonstrating life's ability to thrive in the absence of photosynthesis. The diversity of microbial life in these subglacial environments is staggering. Studies have identified over 4,000 species of microorganisms in Lake Willans, a subglacial lake in West Antarctica. Each new discovery expands our understanding of life's limits and raises intriguing possibilities about potential life on other planets or moons with subsurface oceans. These subglacial ecosystems aren't just scientifically fascinating, they also play crucial roles in global biogeochemical cycles. The microorganisms in these environments are involved in carbon and nitrogen cycling, potentially influencing nutrient availability in the Southern Ocean as subglacial waters eventually reach the sea. As we explore these hidden worlds, we're not just learning about Antarctica, we're gaining insights that could help us search for life beyond Earth. The conditions in these subglacial environments are analogous to those that might exist on icy moons like Europa or Enceladus. By studying life in Antarctica's extreme environments, we're developing tools and knowledge that could one day help us detect life elsewhere in our solar system. But studying these environments presents significant challenges. Accessing subglacial lakes and rivers requires sophisticated drilling techniques to prevent contamination. Scientists must balance the desire for knowledge with the need to preserve these pristine ecosystems. It's a delicate dance of exploration and conservation, pushing the boundaries of our technological capabilities while striving to protect these unique environments. As climate change continues to affect Antarctica, there are concerns about the future of these subglacial ecosystems. Changes in ice sheet dynamics could alter the hydrology of subglacial environments, potentially disrupting these delicate ecosystems. It's a race against time to understand and protect these hidden worlds before they're irrevocably changed. Yet, even as we grapple with these challenges, the exploration of Antarctica's subglacial ecosystems continues to yield new discoveries. Each finding challenges our understanding of life's limits and expands our perspective on potential habitats beyond Earth. As technology advances, future research promises to unveil more secrets hidden beneath the ice, contributing to our knowledge of biodiversity, evolution, and the potential for life in extreme environments across the universe. But the wonders beneath Antarctica's ice don't end with microbes and hidden lakes. Let's dive even deeper into the continent's secrets and explore a discovery that has left scientists astounded: the presence of complex life forms, including fish, living in some of the most extreme conditions imaginable. In 2015, researchers made a stunning find when they discovered fish and other aquatic animals living in perpetual darkness and extreme cold beneath 740 meters of ice in Antarctica. This discovery occurred when scientists lowered a custom-built robot through a narrow hole drilled in the Ross Ice Shelf, a massive glacial formation the size of France. Imagine the excitement as the robot's cameras revealed a community of fish inhabiting a thin wedge of seawater just 10 meters deep, sealed between the thick ice above and the rocky seafloor below. This location is so remote and inhospitable that many scientists had expected to find only microbial life, if any at all. The fish were found approximately 850 kilometers from the outer edge of the ice shelf, the nearest point where sunlight penetrates the ocean and allows for the growth of plankton to sustain a food chain. This raises intriguing questions about how these organisms survive in such an isolated and nutrient-poor environment. The evolution of fish in Antarctica's waters dates back to around 35 million years ago, when the continent began to cool significantly. During this time, a family of fish called Notothenidae began to dominate Antarctic waters, evolving proteins that prevented them from freezing in the increasingly cold conditions. While the exact species of fish found beneath the Ross Ice Shelf are still being studied, their presence suggests a complex ecosystem that has adapted to extreme conditions over millions of years. These fish likely rely on a food chain that begins with bacteria, which serve as food for microscopic organisms called protists. These protists, in turn, are eaten by crustaceans, which become prey for the fish. The discovery of fish in such an extreme environment has implications for our understanding of life's adaptability and resilience. It also raises the possibility of similar ecosystems existing in other subglacial environments on Earth or even on icy moons in our solar system. As we contemplate the existence of these hardy fish swimming in the darkness beneath hundreds of meters of ice, we're forced to reconsider our assumptions about where life can thrive. If complex organisms can adapt to such extreme conditions on Earth, what might be possible on other worlds? But the story of Antarctica's hidden life doesn't end here. There's another aspect of the continent's subglacial environment that's equally fascinating: the presence of vast aquifers and ancient seawater trapped beneath the ice. Recent discoveries have revealed extensive groundwater systems beneath the Antarctic ice, including a large reservoir of salty groundwater in the sediments below the ice streams. This groundwater system is believed to be the largest reservoir of liquid water beneath many ice streams, potentially affecting how the ice flows. The salty groundwater found in these subglacial aquifers provides evidence of past marine incursions. In West Antarctica, which was once an ocean before becoming an ice sheet, the bedrock is covered with a thick layer of sediments containing pore spaces filled with both fresh water from ice melt and salt water from ancient seas. This mixture of fresh and salt water can remain liquid at lower temperatures due to its salinity, potentially lubricating the base of the ice sheet and influencing its movement. The extent of these subglacial aquifers is substantial. In some areas, if the sediments beneath the ice streams were squeezed like a sponge, they could produce a column of water between 220 to 820 meters deep. The presence of this subglacial water system also provides insights into Antarctica's past. The salty groundwater indicates how far inland the boundary between the ice sheet and the ocean, known as the grounding line, once reached. In some areas, evidence suggests the grounding line was at least 70 miles further inland than its current position. As we unravel the mysteries of these subglacial aquifers and ancient seawater, we're gaining a deeper understanding of Antarctica's complex hydrology. This hidden water system plays a crucial role in ice dynamics, potentially influencing how the ice sheets respond to climate change. But there's more to this story than just water and ice. These subglacial aquifers may also host unique microbial ecosystems. While direct sampling remains challenging, the consistent presence of microbial life in other subglacial environments suggests that these aquifers likely contain diverse microbial communities adapted to the extreme conditions. Imagine microscopic organisms thriving in the darkness, feeding on minerals dissolved in the ancient seawater, and evolving in isolation for millions of years. What secrets might these tiny life forms hold? Could they provide clues about the origins of life on Earth, or how life might exist on other planets? The discovery of these extensive subglacial water systems necessitates a re-evaluation of our models of ice sheet behavior and stability. Traditional ice sheet models have not accounted for the presence of such large volumes of groundwater, which could significantly influence ice dynamics, particularly in a warming climate. As we continue to explore and understand these hidden aquifers and ancient seawater, we're not just learning about Antarctica's past, we're gaining crucial insights that could help us predict its future. And in a world grappling with the realities of climate change, this knowledge could prove invaluable. But our journey through Antarctica's hidden wonders doesn't end here. There's one more mystery lurking beneath the ice that has captured the imagination of scientists and the public alike: the Wilkes Land gravity anomaly. Centered at approximately 70 degrees 120 degrees in East Antarctica, the Wilkes Land gravity anomaly is a significant geophysical feature buried beneath the ice. First detected in 1959 to 60 during ground-based seismic and gravity surveys, this anomaly has puzzled scientists for decades. The anomaly is characterized by a large negative gravity anomaly coincident with a subglacial topographic depression. Initially estimated to be 243 kilometers across, more recent data suggest the structure has a diameter of about 510 kilometers. But what could cause such a massive disturbance in the Earth's gravitational field? One intriguing hypothesis is that the Wilkes Land anomaly represents a massive impact crater buried beneath the Antarctic ice sheet. If this theory is correct, the structure would be more than 2.5 times larger than the 180-kilometer Chicxulub crater associated with the extinction of the dinosaurs. Some researchers have even speculated that the impactor could have been 4 or 5 times wider than the one that created the Chicxulub crater. This has led to speculation about a possible link to the Permian Triassic extinction event, the largest known mass extinction in Earth's history, which occurred approximately 250 million years ago. Imagine the cataclysmic event that could have created such a massive crater. Picture a space rock larger than many modern cities hurtling towards the Earth, its impact releasing energy equivalent to millions of nuclear bombs. The devastation would have been unimaginable, potentially altering the course of life on our planet. However, it's important to note that alternative explanations for the Wilkes Land anomaly exist. These include the possibility of a volcanic structure, an igneous intrusion, an ancient igneous diapir, a subglacial sedimentary basin, a glacially eroded subglacial valley, or a tectonic feature. The lack of direct samples due to the thick ice cover makes definitive conclusions challenging. Recent analysis using advanced gravity field models and various gravity aspects has provided additional support for the impact crater hypothesis. These studies have revealed a semicircular structure in both gravity anomalies and subglacial topography, consistent with the characteristics of large impact craters. As we contemplate the possibilities, it's worth considering the implications of such a massive impact event. If the Wilkes Land anomaly is indeed an ancient impact crater, it could provide valuable insights into Earth's geological history, the breakup of the Gondwana supercontinent, and potentially major extinction events in our planet's past. The mystery of the Wilkes Land gravity anomaly serves as a reminder of how much we still have to learn about our planet, even in the 21st century. It's a testament to the power of scientific inquiry and the importance of continued exploration and research. As we conclude our journey through the hidden wonders beneath Antarctica's ice, we're left with a sense of awe at the complexity and diversity of this seemingly barren continent. From ancient river systems to vast volcanic provinces, from extreme ecosystems to puzzling gravitational anomalies, Antarctica continues to surprise and challenge us. These discoveries not only expand our understanding of Earth's history and the resilience of life, but also provide valuable insights into potential habitats for life elsewhere in our solar system. As we face the challenges of a changing climate, the knowledge gained from studying Antarctica's hidden realms becomes increasingly crucial. So the next time you see an image of Antarctica's vast ice sheets, remember that beneath that frozen exterior lies a world of wonders waiting to be explored. Who knows what other secrets the ice might be hiding? As technology advances and our understanding grows, we can only imagine what future discoveries might reveal about this enigmatic continent and its role in shaping our planet's past, present, and future. In the end, Antarctica's hidden landscapes serve as a powerful reminder of the mysteries that still exist in our world and the endless possibilities for discovery that lie ahead. As we continue to unravel these enigmas, we're not just learning about a distant, frozen land. We're gaining insights that could reshape our understanding of life, our planet, and our place in the universe. And so, as we stand on the cusp of new discoveries, we're left with a sense of anticipation and wonder. What other secrets might be lurking beneath the ice? What new mysteries await us in the depths of Antarctica's hidden world? As we peer into the frozen unknown, we can't help but feel a thrill of excitement at the possibilities that lie ahead. Let's dive deeper into the extreme ecosystems that call Antarctica's subglacial environments home. Imagine a world of perpetual darkness, crushing pressure, and near freezing temperatures. It's hard to believe that anything could survive in such conditions, yet life finds a way. Take Lake Vostok, for example. This massive subglacial lake, roughly the size of Lake Ontario, has been sealed off from the outside world for up to 15 million years. You might think it would be a lifeless void, but you'd be wrong. Scientists have discovered a diverse array of microorganisms thriving in its waters, adapted to survive in one of the most extreme environments on Earth. But how do these tiny creatures survive? They've evolved unique metabolic pathways that allow them to extract energy from minerals dissolved in the water. Some even have antifreeze proteins that prevent their cells from freezing in the frigid temperatures. It's a testament to life's incredible resilience and adaptability. Now let's venture into the ice caves formed by volcanic activity, particularly those around Mount Erebus. As you step into these hidden caverns, you're transported to a world that seems almost alien. The walls glow with an eerie blue light filtered through the ice, and steam rises from warm pools on the cave floor. Despite the harsh conditions outside, these caves can reach temperatures of up to 25 degrees 77 Fahrenheit, creating oases of warmth in the frozen landscape. In these surreal environments, scientists have discovered a surprising diversity of life. DNA analysis of soil samples has revealed traces of algae, mosses, and even small invertebrate animals. Some of these organisms are familiar, matching species known from other parts of Antarctica. But others are completely new to science, potentially representing species that have evolved in isolation for millions of years. Can you imagine the excitement of a researcher peering through a microscope, realizing they're looking at a life form never before seen by human eyes? It's moments like these that remind us of the endless wonders our planet still holds, waiting to be discovered. But the implications of these findings go far beyond Antarctica. The existence of life in these extreme environments expands our understanding of the limits of life itself. If organisms can thrive in the dark, pressurized world beneath Antarctica's ice, where else might life be possible? This question leads us to one of the most exciting frontiers in science, the search for life beyond Earth. The conditions in Antarctica's subglacial lakes and ice caves are remarkably similar to those we might find on icy moons in our solar system, such as Jupiter's Europa or Saturn's Enceladus. These moons are thought to have vast oceans hidden beneath their icy crusts, potentially harboring the ingredients necessary for life. By studying the extremophiles of Antarctica, we're not just learning about life on Earth, we're developing tools and knowledge that could one day help us detect life elsewhere in the cosmos. Each new discovery in these hidden Antarctic ecosystems brings us one step closer to answering one of humanity's most profound questions. Are we alone in the universe? As you ponder this question, imagine a future expedition to Europa. Picture a probe melting its way through miles of ice, finally breaking through into a vast alien ocean. What might it find? Perhaps microorganisms similar to those in Lake Vostok, or maybe something entirely unexpected. The possibilities are as vast as the cosmos itself. But our journey through Antarctica's hidden wonders doesn't end here. There's another aspect of the continent's subglacial environment that's equally fascinating: the presence of vast aquifers and ancient seawater trapped beneath the ice. Recent discoveries have revealed extensive groundwater systems beneath the Antarctic ice, including a large reservoir of salty groundwater in the sediments below the ice streams. This hidden water world is not just a curiosity. It could play a crucial role in the dynamics of Antarctica's ice sheets. The salty groundwater, a remnant of ancient seas, might act as a lubricant at the base of the ice, potentially influencing how the ice flows in response to climate change. But let's shift our focus to another fascinating aspect of Antarctica's hidden treasures: its role as a cosmic vault. Believe it or not, this frozen continent is one of the best places on Earth to find meteorites. Why? The answer lies in the unique conditions that Antarctica provides. Picture vast ice fields stretching to the horizon. As meteorites fall onto these expanses, they become embedded in the ice. Over time, the slow movement of glaciers concentrates these space rocks in certain areas. The dark color of the meteorites contrasts sharply with the white ice, making them easier to spot. It's like nature has created its own cosmic sorting system, delivering these extraterrestrial samples right to scientists' doorstep. Since 1969, over 45,000 meteorites have been recovered from Antarctica, representing about 2/3 of all meteorites collected worldwide. Among these cosmic treasures are rocks from the Moon and Mars, providing invaluable samples of these celestial bodies without the need for costly space missions. Can you imagine the thrill of holding a piece of another world in your hands? These meteorites offer crucial information about the formation and evolution of our solar system, helping us piece together the cosmic puzzle of our origins. But Antarctica isn't just a repository for space rocks. It's also a treasure trove of human history. Despite its lack of indigenous population, the continent contains significant archaeological sites from the heroic age of Antarctic exploration in the late 19th and early 20th centuries. Picture yourself standing in front of a small wooden hut, weathered by a century of Antarctic storms. This is Captain Robert Falcon Scott's hut at Cape Evans, preserved almost exactly as it was left in 1912. Inside, you'll find food cans still on the shelves, scientific equipment laid out on tables, and even the expedition members' personal belongings. It's like stepping into a time capsule, offering a poignant glimpse into the lives of these early explorers. Nearby, you might stumble upon the remains of early sealing and whaling stations, silent testaments to the industries that first brought humans to this remote continent. These sites provide valuable insights into the early exploitation of Antarctic resources and the beginnings of human presence in this harsh environment. But perhaps the most exciting recent discovery is the wreck of Sir Ernest Shackleton's ship Endurance, lost in 1915 and found in 2022 at the bottom of the Weddell Sea. The ship lies in remarkably good condition, preserved by the cold waters and lack of wood-eating organisms. Its discovery is a triumph of modern technology and human perseverance, echoing the spirit of the original expedition. These archaeological sites face unique preservation challenges. The extreme cold and dry conditions that have kept many artifacts intact for decades are now under threat from climate change. Increased melting and humidity could accelerate the deterioration of these invaluable historical resources. Conservation efforts are ongoing to protect both the meteorites and historical sites of Antarctica. International agreements, such as the Antarctic Treaty System, help regulate the collection of meteorites and the preservation of historical sites. Scientists and conservators work tirelessly to document and preserve these treasures, racing against time and changing environmental conditions. As we reflect on these cosmic and historical treasures, we're reminded of Antarctica's unique role as a preserver of both extraterrestrial materials and human heritage. Each meteorite and each artifact tells a story of the formation of our solar system, of human courage and exploration, and of our ongoing quest to understand our place in the universe. But our journey through Antarctica's hidden wonders isn't over yet. There's one more mystery lurking beneath the ice that has captured the imagination of scientists and the public alike: the Wilkes land gravity anomaly. This massive geophysical feature, buried deep under the East Antarctic ice sheet, has puzzled researchers for decades. Some speculate it could be the scar left by an ancient impact event, while others propose alternative geological explanations. As we prepare to delve into this enigma, consider the possibilities. Could this anomaly be evidence of a cataclysmic event that shaped Earth's history? Or is it a testament to the complex geological processes that have shaped our planet over millions of years? As we ponder these questions, we're reminded once again of the countless mysteries that still lie hidden beneath Antarctica's icy surface. The Wilkes land gravity anomaly, centered at approximately 70 degrees 120 degrees in East Antarctica, is a geophysical feature that has puzzled scientists for decades. First detected in 1959 to 60 during ground-based seismic and gravity surveys, this anomaly has continued to intrigue researchers with its sheer size and mysterious origins. Picture yourself flying over the vast expanse of East Antarctica. Below you, hidden beneath miles of ice, lies a structure so massive it alters the Earth's gravitational field. The anomaly is characterized by a large, negative gravity anomaly, coincident with a subglacial topographic depression. Initially estimated to be 243 kilometers across, more recent data suggest the structure has a diameter of about 510 kilometers. That's more than twice the size of the Chicxulub crater associated with the extinction of the dinosaurs. But what could cause such a massive disturbance in the Earth's gravitational field? One intriguing hypothesis is that the Wilkes land anomaly represents an ancient impact crater buried beneath the Antarctic ice sheet. Imagine the cataclysmic event, that could have created such a massive crater. Picture a space rock larger than many modern cities hurtling towards the Earth, its impact releasing energy equivalent to millions of nuclear bombs. The devastation would have been unimaginable, potentially altering the course of life on our planet. Some researchers have even speculated that the impactor could have been 4 or 5 times wider than the one that created the Chicxulub crater. This has led to speculation about a possible link to the Permian-Triassic extinction event, the largest known mass extinction in Earth's history, which occurred approximately 250 million years ago. Can you imagine the implications if this theory proves correct? We could be looking at evidence of an event that reshaped life on Earth, hidden for millions of years beneath the Antarctic ice. It's a reminder of how our planet's history is written not just in rocks and fossils, but in the very shape of the land itself, even when that land is buried under miles of ice. However, it's important to note that alternative explanations for the Wilkes land anomaly exist. These include the possibility of a volcanic structure, an igneous intrusion, an ancient igneous diapir, a subglacial sedimentary basin, a glacially eroded subglacial valley, or a tectonic feature. The lack of direct samples due to the thick ice cover makes definitive conclusions challenging. So, how do scientists study something buried so deep beneath the ice? They use a variety of sophisticated techniques. Satellite measurements of the Earth's gravitational field provide crucial data. Ice-penetrating radar helps map the topography beneath the ice. Seismic surveys offer insights into the structure of the rock below. Recent analysis using advanced gravity field models and various gravity aspects has provided additional support for the impact crater hypothesis. These studies have revealed a semicircular structure in both gravity anomalies and subglacial topography, consistent with the characteristics of large impact craters. But the mystery doesn't end there. The Wilkes land anomaly is just one piece of a larger puzzle about Antarctica's geological history. How does it relate to the breakup of the ancient supercontinent Gondwana? What can it tell us about the formation of the Antarctic ice sheet? These questions continue to drive research and exploration. As we contemplate the Wilkes land anomaly, we're reminded of how much we still have to learn about our planet. Even in the 21st century, Earth still holds secrets waiting to be uncovered. The existence of such a massive hidden structure challenges our understanding of Earth's geological history and the forces that have shaped our world. Imagine future expeditions to this site. Picture scientists drilling through miles of ice to reach the bedrock below, eager to uncover physical evidence that could confirm or refute the impact crater hypothesis. What might they find? Shocked quartz crystals that could prove a massive impact? Or perhaps geological formations that point to a different origin entirely? The Wilkes land gravity anomaly serves as a powerful reminder of the dynamic nature of our planet. It speaks to the immense forces, both extraterrestrial and geological, that have shaped Earth over its long history. As we continue to study this enigmatic feature, we're not just learning about Antarctica's past, but gaining insights that could reshape our understanding of Earth's geological history and the cosmic events that have influenced life on our planet. But our journey through Antarctica's hidden wonders doesn't end here. There's one more fascinating aspect of the continent's subglacial environment to explore: the presence of ancient fish and vast aquifers trapped beneath the ice. Imagine a world sealed off from the surface for millions of years, where life has evolved in isolation under the most extreme conditions. In 2015, researchers made a stunning discovery when they found fish living in perpetual darkness and extreme cold beneath 740 meters of ice in Antarctica. These fish, adapted to survive in near freezing temperatures and complete darkness, challenge our understanding of life's limits. Scientists believe they rely on a food chain that begins with bacteria, which serve as sustenance for microscopic organisms called protists. These protists in turn become prey for small crustaceans, which the fish then consume. But how do these fish survive in such an isolated environment? The answer lies in their remarkable adaptations. Many Antarctic fish species have evolved antifreeze proteins in their blood, preventing them from freezing in the frigid waters. Some have even lost their hemoglobin, the oxygen-carrying protein in blood, as the oxygen-rich cold waters allow them to absorb enough directly through their skin. As you contemplate these hardy creatures, swimming in eternal darkness beneath hundreds of meters of ice, consider the implications for our search for life beyond Earth. If complex organisms can adapt to such extreme conditions on our planet, what might be possible on the icy moons of Jupiter or Saturn? But the story of Antarctica's hidden life doesn't end with fish. Beneath the ice lies another astonishing discovery: vast aquifers of liquid water. Recent research has revealed extensive groundwater systems beneath the Antarctic ice, including a large reservoir of salty groundwater in the sediments below the ice streams. Imagine a sponge the size of a continent, saturated with a mixture of fresh meltwater and ancient seawater. This is essentially what lies beneath much of Antarctica's ice. In some areas, if the sediments beneath the ice streams were squeezed, they could produce a column of water between 220 to 820 meters deep. The presence of this subglacial water system provides crucial insights into Antarctica's past and potential future. The salty groundwater indicates how far inland the boundary between the ice sheet and the ocean, known as the grounding line, once reached. In some areas, evidence suggests the grounding line was at least 70 miles further inland than its current position. But why does this matter? These subglacial aquifers could play a significant role in ice sheet dynamics. The mixture of fresh and salt water can remain liquid at lower temperatures due to its salinity, potentially lubricating the base of the ice sheet and influencing its movement. As our climate continues to warm, understanding these hidden water systems becomes increasingly crucial for predicting how Antarctica's ice sheets might respond. Moreover, these aquifers may host unique microbial ecosystems. While direct sampling remains challenging, the consistent presence of microbial life in other subglacial environments suggests that these aquifers likely contain diverse microbial communities adapted to the extreme conditions. As we conclude our journey through Antarctica's hidden wonders, we're left with a sense of awe at the complexity and diversity of this seemingly barren continent. From ancient river systems to vast volcanic provinces, from extreme ecosystems to puzzling gravitational anomalies, Antarctica continues to surprise and challenge us. These discoveries not only expand our understanding of Earth's history and the resilience of life, but also provide valuable insights into potential habitats for life elsewhere in our solar system. As we face the challenges of a changing climate, the knowledge gained from studying Antarctica's hidden realms becomes increasingly crucial. The continent serves as a natural laboratory for studying climate change. The ancient air trapped in its ice cores provides a record of Earth's climate stretching back hundreds of thousands of years. The behavior of its ice sheets offers clues about future sea level rise, and the unique ecosystems beneath its ice challenge our understanding of life's limits, with potential implications for the search for life beyond Earth. As technology advances and our understanding grows, we can only imagine what future discoveries might reveal about this enigmatic continent and its role in shaping our planet's past, present, and future. Each new finding underscores the importance of preserving Antarctica's pristine environment for scientific research. In the face of rapid global warming, Antarctica stands as both a warning and a beacon of hope. Its melting ice sheets remind us of the urgent need to address climate change, while its hidden wonders inspire us to continue exploring and learning. So the next time you see an image of Antarctica's vast ice sheets, remember that beneath that frozen exterior lies a world of wonders waiting to be explored. Who knows what other secrets the ice might be hiding? As we continue to unravel these enigmas, we're not just learning about a distant frozen land. We're gaining insights that could reshape our understanding of life, our planet, and our place in the universe.